Welcome to the Communicable disease section. We've been doing a lot of this on quizzes and whatnot in different sections. I'm now just going to give you a little bit of an overview to support you with your work for next week and some of the quizzes. You'll also be getting some videos through GCSE Pod which will help, but hopefully I can help you a little bit more to give you an overview and a basic understanding of this topic. So we're going to look at what makes us ill. We're going to look at communicable diseases as one of the topic titles here. So let's look at the differences first of all. Communicable diseases can be passed from one person to another, where non-communicable cannot. We know there's examples of them, such as like the flu, the common cold, and non-communicable such as cancer that developed inside the body. Both will make us ill. There are other factors that contribute to us being ill, such as a diet, stress, and the life situations that we're in. Starvation, rickets, heart disease, cancer, but other life situations as well, where stress can be a big factor too. And link the two together. Let's look at these disease-causing organisms that we're talking about here. The four main ones that we need to know are bacteria, the virus, the fungi, and the protists. The two types of these pathogens that we really need to go down into a little bit more detail are the bacteria and the virus. So bacteria is a single bacterium on its own. Mainly the four things we need to know about really are that it's very similar to I suppose a plant cell in one way and an animal cell in another way, but it's not either. It doesn't have that nucleus, it's got loose genetic material. There's still cytoplasm, still a membrane allowing substances in and out. There's a cell wall as well, and you'll notice that too. If we look at the virus, you'll notice the virus is a very different picture. A lot smaller. I mean, I can't comprehend how much smaller a virus is than a bacteria. And we're currently understanding a lot more about the virus, given our situation with COVID-19 and how we protect ourselves from it. This is very different. Like I said, there's a tail plate which will join onto a cell. There's loose material that will be injected into a cell to reproduce itself. There's an injection tube that assists with that, and there's a coat that holds all the protein in place. Now, interestingly, again, like I said, they're a lot smaller, but they also come in different shapes. So this shape isn't just the only shape that the virus comes in. We can see viruses in all different types of shapes, such as round shapes with lots of different prongs on them to inject their protein, to inject their genetic material. So have a look at that too. I thought I'd just show you the two types of pathogen where their common illnesses occur from each one. So, like viruses, we know about this one. We know about the flu already. We talked about that a lot. And we've got mumps, chickenpox, smallpox. That similar family there of virus. Polio, rabies, and German measles. Bacteria is slightly different. Like I said, bacteria it looks different. It has a different format. There's food poisoning, sore throats, TB, tetanus, cholera, typhoid, and whooping cough. And some common illnesses that you will need to know a little bit about. So these microbes, these very small pathogens, they enter the body in different ways. I've censored out the man's genitals just because it's too early in the morning to see that. But we've got our eyes, we've got our eyelashes, and we can protect ourselves with that film, and we've got that liquid in our eyes that can help with that. We've got our ears, with the same with the hairs in our ears, we can protect ourselves a little bit. But these are how they're going to get in. We've got our mouth, we can get in, again we've got cilia that beat up and rid us of all that, and all different types of ways to stop those microbes coming in, but they will still come in. They are still entrances into our body. We can see we've got our nose as well, which is part of the nasal cavity. Again, hairs will trap some dirt and some pathogens and some microbes, but we are going to have that. Our skin is one of our biggest defences. It gives us that layer around our body. Our genitals, we can, also anything can enter inside our genitals. The skin will allow substances in and out. So again, it is protecting our body, but it's also quite susceptible to letting stuff in, especially when we get cut, especially when we cut the surface, and that's what we're mentioning here. So let's look at how we deal with this. So our body can deal with some disease in our body when it occurs. So what happens is if those microbes enter the body and produce the toxins, those toxins are coming from the bacteria. And we're talking specifically in this area about bacteria. So the microbes will reproduce more and more toxins and make the body ill, or make that section of the body ill and inflamed and infected. The white blood cells start to replicate and try and kill this off. And what they do is they make an antitoxin to rid us of that pain and that toxin that's inside, and they build antibodies too, and those antibodies can remember for a longer period of time. They then overpower the microbes. They overpower them, engulf them in most cases, which is phagocytosis, it's quite a long word, and that can engulf those microbes and rid the body of them, and the person will be well again. So vaccines contain a small amount of dead or weakened pathogen particles. The vaccine stimulates the production of antibodies and memory cells against the target pathogen without making the person ill. Well, it slightly makes the person ill, but only very slightly. So what it does is stimulates that white blood cell reproduction of antibodies. Now this was the Edward Jenner story. You would have heard of this, where he found this out through the cowpox of the girls that were milkmaids, and it effectively protected them against the very dangerous smallpox that was around at the time. So a good story to look up is the Edward Jenner story about how vaccines were created. But vaccines are simply a small amount of that bad pathogen where our body can then reproduce the antibodies required to kill it off. And this works with viruses in the way that it does. Not for bacteria. We'll talk about what works for bacteria shortly. So this is the guy, Alexander Fleming. This is the guy that found this first antibiotic. And what he did was he accidentally left some mold in one of the petri dishes in his lab, and noticed that when he came back, it had killed off the bacteria that lived around that mold and that fungus that was sort of growing within that petri dish. And what he noticed was that if we injected that into the body in a certain form, we could effectively kill off the bacteria around that area. His first one being penicillin, and obviously things have moved on since then, and we're now finding that we've got antibiotics for all sorts of different bacteria. So if we want to get these antibiotics or any kind of drug through the system into our public health system where we can actually give them out in pharmacies, they have to go through quite a serious amount of trials and cost millions of pounds to develop. So as we can see here, we take out tissue samples at first, so there's no harm to anybody or anything. Often then we'll look at animal testing, and that will test for toxicity. That obviously has its ethical issues, which will be discussed on another part of this topic. And we then clear it for human testing. And then humans will be able to have it tested on them. Often it's by choice and they get paid for it. Unfortunately, animals don't get any reward for it. Then it goes to the human testing stage. So when we get it to this point where we feel that it's safe enough to put into a human, we give healthy volunteers a chance at it. Like I said, paid, and they opt in for that. And we look at their side effects. Then what we do is they kind of look at the placebo effect, where someone would have the real drug and someone would have the fake drug, but they wouldn't know. They call that a double blind. If they don't show the doctor it, they don't show the patient it, only the medical, the drug provider or the laboratory will give that drug out to the doctor and won't tell them which one is which. And then they'll look for the effects and the effectiveness of that drug. It then goes to a large number of people, so take it from a small group to a large group to see if there's any wider effects on different types of people with different health conditions, and then it gets licensed. And like I said, we're talking millions of pounds to get to this stage.